Hello, everyone. Thank you for joining us today. Our presentation, it's a co-presentation between myself, Neil Chauhan, and Sina Karimi. I am part of R-E-A-L.iT. Sina is part of Pomerleau. I consider Sina a partner of ours instead of a customer, and that's how we consider all of our customers. So we will be talking about autonomous reality capture solutions for quality inspection in construction. What we will do is, first I will define what autonomous reality capture actually is as a concept. Then we will go into some current solutions that we provide here at R-E-A-L.iT, mainly the BLK2GO, the BLK2FLY, and the BLK ARC. The BLK ARC, I'll go into a little bit more detail of the technical specs, and then I'll give it to Sina to talk about a case study, because without case studies, without hard evidence, this is all just hearsay. And then we'll have a Q&A session at the end. Just a little bit of background of myself and Sina. So as I said, I'm part of R-E-A-L.iT. I am a reality capture solutions consultant. My background is in the architecture, engineering, and construction, mainly construction industry. I have a civil engineering technology background as well as a construction management degree. My background is terrestrial and mobile 3D laser scanning, scan registration, 3D point cloud processing for the bulk of about 10 years now. And at the end of the 10 years, I've also been a manager of data capture teams and also data processing in the office. I have a passion for reality capture and the technology for spatial data collection. My focus is on custom and innovative solutions for partners in North America. As for Sina, he is a R&D specialist at Pomerleau. His focus is on robotic applications development for construction projects. His background is he's an architect and assistant project manager. His emphasis is on construction automation for increased productivity in construction. He has an architectural engineering bachelor's degree from University of Tehran, a master's degree in construction engineering. And he has a passion for robotics, AI, and AR and VR in AEC. So it was a natural match for us to present this together. He has some published works as well, which you can take note of. So what is autonomous reality capture? It refers to the process of using automated and self-operating technologies, such as drones, robots, or specialized cameras, to capture real-world environments in the form of digital data. This technology is commonly employed in industries like construction, architecture, and engineering to create accurate and detailed representations of physical spaces. By removing the need for manual intervention, autonomous reality capture streamlines data collection, enhances accuracy through repeatable results, and improves efficiency in tasks such as quality inspection, site monitoring, and 3D modeling. As well, safety of on-site workers is also increased because they no longer have to enter confined spaces or hazardous environments. Autonomy. So the definition of autonomy is, in reality capture especially, involves a self-operating technology for data collection without constant human intervention. The benefits of autonomy is the reduced manual labor. Automation minimizes the need for manual data collection and piloting. Time and cost savings as well. Autonomous systems enable quicker decision-making and reduced resource requirements. The future implications for autonomy in reality capture is that it holds promise for further efficiency gains, real-time insights, and seamless integration with project management processes. Current solutions that we provide. An example is the BLK2GO. The BLK2GO presents a valuable asset for general contractors. It's portable, handheld, And the design facilitates efficient 3D scanning on site, aiding in precise as-built documentation. This contributes to smoother project management, quicker quality assessments, and improved communication among all stakeholders. The BLK2Go's time-saving features make it an essential tool for enhancing construction processing and achieving project success for large general contractors. Another solution is the BLK2Fly. So the BLK2Fly is similar to the BLK2Go, but it is a drone-based scanner. It also allows for autonomous flight. The BLK2Fly can navigate predefined routes without manual piloting. Automated scanning, it captures aerial data using LiDAR and imaging sensors, ensuring accurate and comprehensive coverage. And you get efficient site analysis. Autonomous flights allow for quick site assessments and progress monitoring because you can save that predefined flight and have your own frequency of performing that flight. And finally, the BLK ARC. This is a self-guided, the BLK ARC's mobility enables it to move autonomously within the space, capturing data from various angles. So the BLK ARC is the scanner itself. It could be mounted to various robotic solutions. It also integrates with that robotic solution for onboard intelligence, avoiding obstacles and optimizing scanning patterns, ensuring thorough and efficient data collection. As well, the autonomous movement enables complete as-built documentation without constant user input. Some more stats. So again, you can remotely use the BLK ARC on top of any robotic solution. The BLK ARC also employs a Grand Slam technology to support navigation. It's also capable of static scanning as well as the mobile scanning during the same campaign or mission. And you can also plan its path offline and have it perform whenever you please. Just some stats. So the scanner itself scans about, at least 500,000 points per second, about. It has a full dome LiDAR sensor, multi-camera vision system. The range is about 0.5 meter to 25 meters. And the mounting hardware is for robotic integration. But you can mount it on non-robotic solutions as well. It employs a LiDAR slam, a visual slam, and an IMU to constantly make sure that the point cloud is crisp and accurate. And with that, I will give it to Sina to go through his portion of the presentation and present a case study.
Thank you, Neil. Hi, everyone. I'm Sina with Pomerleau. So now we are going to go through our journey with autonomous reality capture using different scanners and any robotic platform. So the first of all is about construction managers, or some as may say general contractors and robotics. So the first question that comes to mind is that why can it be useful to use robots for reality capture on a construction site? Well, the work is dull and difficult for a human. For example, being able to take a photo or a laser scan at the same time, at the same location, at the same time of day, with the same lighting condition could be very challenging. And you have to be careful that you have to do it day after day and after day. So the people who assign to that level of reality capture, they are typically going to bring more value to the project by working on other things. So with robots, we increase the amount of frequency of data that we collect on our job site while decreasing the labor hours, keeping everybody focused on higher added value tasks. When it comes to fixed sensors, there is a huge limitation there. And also there's a risk. What if something gets in the way of a fixed sensor? It's a construction site. It's ever changing, very dynamic. So something might come in between. So we want an agile platform to be able to detect obstacles, avoid them and go around them to be able to capture the site comprehensively. And those robots are capable of collecting data at the same location at the same time of day. Just imagine that we are humans. We don't go necessarily to the same location, but a machine or a robot is actually capable of going to the same location. By doing that, the downstream analysis, such as machine learning or computer vision algorithms, they work more effectively. And that gives an answer to the need of enabling data-driven decisions on job sites. So our R&D team at Pomerleau is focused to use automation with robotics, trying to help with the problem to effectively monitor and manage job sites. That level of comprehensive site visibility requires unprecedented amount of data to be collected. The reality could be captured in different ways, and it could be through a drone, it could be ground robots, it could be leg robots. You've seen the spot upstairs in the booth that how it actually is able to navigate on the construction site. So it can very easily and smoothly handle stairs and obstacles on a job site. And the frequency of the data capture are really important for actual site visibility. So by using robots, we are able to collect the data frequently. Now we are looking at 5 major steps of reality capture, which are highly labor extensive, and we aim to add automation not only at each step, but also to transition from one step to the other. It's not only about capturing the data. It's also about migrating the data to cloud-based platforms. You've seen many cloud-based platforms these days that they offer services. So actually, the robots are able to collect the data and then push into the cloud for further analysis. So our robots help in the first 3 steps. First of all, we plan for the robot. We plan the mission for spot. We capture the data and then we transfer them to our experts. In this case, we also try to reduce the commute hours to projects to generate higher efficiency in our processes. The last 2 steps are happening within our software ecosystem. The people who are doing the analysis, they are not part of the on-site data capture team. They are off-site. Sometimes they don't even know that there is a robot capturing the data. All they know that is that they are receiving the data frequently, almost real time. So when it comes to the use of robots on job sites, the first thing that we ask is that what is the right tool and how we can generate more value. It could be a drone, it could be a ground robot. So it's actually about the right tool for the right job. A dynamic platform is always needed, which can capture accurate data. Due to exclusive nature of construction projects, we should consider which tool fits the job. So the type of job is important. Also, the current workflow works perfectly fine. So we need to understand where we fit within that workflow. We also want a platform that is able to have a higher predictability, and it has effective duration of autonomy. You don't want to swap batteries every time. So you want a platform to be able to cover the whole job site with only one or 2 batteries. So we collect different types of data. So the platform should be able to be customized to various payloads. Sometimes it could be 360 image. Sometimes it could be laser scans. It could be thermal images, gas sensors. There are different types of data that we collect with the robot. So we wanted something to be able to customize it ourselves. That's why we are working with Boston Dynamics. About the applications of autonomous data capture, we have 3 applications that we are working at Pomerleau. Site progress monitoring, quality assurance, and workers' health and safety. I'm not going to go deeper into Spot. I'm sure that you've seen Spot upstairs, so you're actually familiar with how it maneuvers and how it motions in an environment. So we have many projects working and coordinating in 3D in BIM. We want to be able to compare as built versus as modeled. There are different ways to do that. You could always go traditional, But we should be careful that today we talked a lot about labor shortages. We want our people to be focused on higher added value tasks. So that's why we use robots for only the data collection part. Here we use Spot for site progress monitoring, where we capture 360 images and also laser scans to be able to track the progress on our site. We also extensively use Spot for quality assurance. So this is also something that we do for most of our projects, and we are trying to add limitations with Spot. And also at the end, I cannot emphasize enough that first and foremost, safety is our first concern. So think about pre-port decking that some kind of injury might happen, but also think about confined spaces that there could be some hazardous situation happening for a human to go there. So we don't want to risk a person to do that level of reality capture. We send the robots, so they go inside. Like you see in the picture, Spot is coming back from his autonomous mission with lights on his camera to illuminate the confined space to be able to capture data, and then our team analyzes and identifies the hazardous situation, and they take action for those items so that they don't continue to be in danger. So about our journey with Spot and also robotics. First of all, our journey with Spot starts with job site monitoring. We capture 360 photos, usually once or twice a week. It really depends on the job site and what you want to do with it. We take those photos frequently over time to understand progress and deal with disputes. In this slide, we once record you're seeing a Spot that is equipped with a 360 camera. We want to record a path for the robot to understand where to go and how and where to take an action. So in this case, the action is taking a 360 image, so that the robot understands the environment. And then we repeat that process. It's very intuitive. It doesn't require expertise in robotics. It's very intuitive. You just hit start button and it goes autonomously. And if there is anything on its way, Spot is able to capture to understand the obstacle, the environment, and then avoid those and also find its way on its path. The second one is about laser scan. So it was a couple of years ago that we integrated RTC 360 with Spot to support surveying work. In this picture, you're seeing different components that come and work with the Spot. And in this case, if you're familiar with RTC 360, it's a highly accurate laser scanner. I'm not an expert in terms of laser scans, but I would refer you to Neil for further specifications. The first question that we had with Spot on our job site is that, can the robot collect the right data at the right location consistently? So that was our first case study. We wanted to understand if the robot is able to collect the right data. Some people would argue that, well, the robot is not intelligent enough. You always need human intelligence to do that. So we wanted to understand that how it works. And then we wanted to examine that, can the robot handle typical obstacles and change in site conditions? Again, construction sites are ever changing. They are very dynamic. Today, there might be something on the path which may not exist tomorrow, or something new comes in the week after. So it's always there's always change. So the robot needs to understand the environment and avoid those obstacles. Does it perform effectively and safely alongside other activities on site? We don't want to interrupt your regular operation on job site. So we want to understand that how the robot can work alongside other activities. And what type of mission can the robot perform? And also, how will site operators leverage the data collected? I work at Pomerleau as a robotic expert, but I'm not the one on the job site collecting the data. So it's always one of our VDC team who take control of the robot. They receive 1 or 2 days of training to work with the robot and understand it. And then this is how we enable autonomous reality capture on site. So in this slide, you are seeing same condition on one of our job sites that we used RTC 360 with a tripod and also with a spot. You're seeing here in the heat map that the data is very comparable and there's very minor changes. The changes is about some obstacles on the ground. So in terms of numbers, there is a bit of path planning at first, but it's only one time setup. In our process that we tested, we actually deployed Spot. We started measuring and capturing KPIs. So we started observing 95 minutes of time saved or improved productivity per week, which is per scan. So imagine that you scale it up in a project that takes a year or 2 or 3. So we observed 95 minutes per week on an 1,100 square meters of a job site. We save $12,000 per week with Spot. Or if you want to interpolate the data, we can say that we saved $10 per square meter per week. Sometimes we talk with our project managers. They want to have some metrics, some numbers that how it can generate value on my construction site. So by having a specific number per square meter, you're able to calculate approximately how much generate they can value on their job site by deploying autonomous reality capture. The second case study is with the BLK ARC. Neil already talked about BLK ARC, so I'm not going to go deeper into that. But we used BLK ARC on the spot for the past year. We've been using it consistently on one of our job sites. So it's always been on job site, working, scanning, collecting data for quality assurance. We've seen great numbers with that as well. That I'm going to get into that. All that we are talking about here are direct ROI. So these are tangible numbers that we collected from our job sites to understand how this robot can generate value for a construction manager. We observed 60 minutes of improved quality per week for 1,000 square meter of a project. It's a bit different than RTC 360 because those two laser scanners, they work in different way. That's why you're seeing different numbers here. And almost we saved $7,200 per week or $7.2 per square meter per week. Imagine that if we scale up this number to a project of 2, 3, 5 years, how much value we can generate with autonomous reality capture. And it's just the tip of the iceberg. There are some indirect ROIs that are kind of challenging to measure and quantify. First of all, is remote control. You don't have to be in hazardous situation anymore. So you just send the robot for autonomous mission, and then it comes back. You have all your data. You push it to the cloud, and then it's there. You start working with the data consistently. It has seamless integration. You don't have to develop everything from scratch. There are solution in the market that you can buy off the shelf to put it on the spot. An example is BLK ARC. I saw that there's also another example upstairs with Trimble that they also provide turnkey solutions for Spot. If you're familiar here with machine learning and how it works, when we bring consistency in data collection, we are also improving our machine learning algorithms. So they work better with change and error detection. By doing frequent data collection, we detect errors earlier, so we avoid rework and extra cuts. And also enhanced communication. It's a wide term. I'm not saying that it's the only means of communication, but also it contributes to communicate among different stakeholders. So from now on, I'm going to talk about our journey with the Spot from R&D to deployment. So implementing robots in the field can be intimidating. Here is a deployment roadmap that any organization can use to leverage robotic technology. We've been working with Spot for more than 3 years. We kind of developed the expertise, and we are here to share that with the industry for others to leverage autonomous reality capture. So first of all, you need to formulate a value hypothesis. So we have a team with the skill set to develop and integrate solution, and also we got the buy-in from our executives to test our hypothesis. Then we design simple qualitative experiments. It doesn't have to be very complicated. We tested our hypothesis as simple as asking, how can the robot add value? We articulated direct and indirect ROI targets, helping to prioritize development of solutions for Pomerleau's needs. Then we went ahead with a kickoff initial proof of concept. So we tested our proof of concept on the job site to understand that how it works, because we always wanted to test our hypothesis. Then we built a simple prototype, which first it was with the 360 camera, then with the laser scanner. And after that, we developed application. We tested our application, and also after that, we developed application for our project sites, and then we handed over those developments to site operators. Those they There's not like a big learning curve there. We just train our people on site to understand how to work with the robot. No, it's a robot that it's very cool. When you go on the job site, everybody wants to take a picture. Everybody wants to take a video for their kid. So they need to understand how to interact with the robot because the robot is responsive to the environment. So if you jump in front of the robot, it tries to avoid you as an obstacle. So it starts, reacting to site conditions. So we wanted our people in the field to understand the different complications of having a robot on a job site. Then for incremental POC testing, which is a bit deeper in one of our steps, we went very simple. So at first we tested the mobility. Can the robot go everywhere it needs to go on job site? Can it handle stairs? Can it handle slopes? There are different features there are different situations that the robot can start. So what are those features? So we tested the mobility. Then we went ahead with autonomy. We have a robot for autonomy. So this is the core of our hypothesis. How can we actually put that autonomy into our job site? So we started testing autonomy in our construction site. Then we started collecting data. Then we started collecting data. We wanted to understand if we are able to collect the sensor data we need, such as high resolution images, high quality point clouds. The robot is actively in motion. So are there any blurs in images? Are there any reduced quality in our laser scan? Which wasn't the case. And then we wanted the robot to do necessary tests and conduct a value experiment. We wanted to test the full application from A to Z to understand how we can generate value for the robot on our job site. And at the end, we piloted on the project. We handed the application over to a supervisor on the job site. We ran the robot on a daily and sometimes on a daily, but mostly on a weekly basis. Then we started measuring the ROI metrics to calculate direct and indirect ROI. Then we iterated based on the results. So there's always a new application that we are thinking about on how we can generate more value with robotics on site. So that brings me to the end of this presentation. If you have any questions, Neil and I are available to answer those. Thank you.
Thanks, everyone.
Thank you. Thank you.
Yeah.
I guess my question would be, if you're scanning that frequently, how are you kind of controlling the data? Because that's got to be terabytes of data.
Yeah. We are actually working with some of our partners that they have. They are also working with AWS or some of those providers. So that's how we handle the data. Yes, that's going to be massive amount of data, but then we have some data governance in place at Pomerleau. So after the project is done at some point, then we hand it over to our data folks, and after that, it's up to them if they want to keep the data or if they want to replace it with other types of data.
So do you kind of have a process then where you cull redundant data as the project evolves?
Yes.
Okay.
Thank you for the presentation. For the quality assurance, once you collect the point cloud, how do you compare it with as these designs? It's manual process or automated?
Sorry.
So you collect the data at the point cloud, and you need to maybe compare it with the drawings or as designed models. How do you do that? Is it an automated process, semi-automated, manual?
I guess, is that downstream from you?
Yeah, it's kind of a downstream analysis.
So how is this process? Is it automated process or is manual, just checking this quality assurance that you talked about?
I mean, there are many ways to skin a cat, right? In this way, I would say it would be more or less manual because you are comparing data sets, frequent data sets, right? There are automated processes as well, scripting that can occur, that can be written to automate this process, generate reports. It really depends on what you're using the data for and why you're capturing, right? So,
For progress monitoring, do you quantify the progress or just?
you would have to, right?
Yes.
There would be no use if you weren't quantifying that data.
So again, this quantification is it automated or?
I wouldn't say it's automated. I would not say. We'll talk about solutions that can be presented for that. Yeah.
I was just looking for a little bit of clarity on the ROI for the case studies there. So you mentioned that it was saving about an hour a week. Did I understand that correctly?
Yes, we're sitting now.
Okay, and then I think the
For 1,000 square meter project.
an hour a week for 1,000 square meter project, and then and the dollar savings was $7,000 a week.
Yes, it was $12,000 a week.
$12,000. So am I to understand that the person who does this job makes $12,000 an hour, or do I have my math wrong?
Well, it's not actually that way. That person is part of our project team. So instead of collecting data, they are going to be working on other tasks. So it's not that you pay that person.
So the value created by
Yes,
freeing up that
exactly.
person is equivalent to $12,000 a week.
Yeah,
Understood.
correct.
Do you use the data to collect it to like any Revit models or any 3D data, or any like sort of schedule to track the milestones or the project schedule? What would you say?
Oh, well, we use the data. It goes back to the question why you are collecting data that Neil was saying. Sometimes you're collecting data for creating as-built models, so that then you will loop it back to, let's say, Revit, and then you start, kind of see what the difference is, and then you start, modeling. Sometimes it goes to like a product which is Cyclone 3D. Yeah, and then you can start, processing the point of the error.
Right. Meaning the case study that you guys did you like was there any connection to the Revit model, or I just want to know like what process you guys have, because that's some of the issues that we're facing sort of like with the current project where you're not connected to the site as much as we want to be, and also that there's always that gap in the schedule and what's being done, and sometimes it costs us so much because we do not look at that. So tools like this would be helpful, but I'm curious to see like how Pomerleau is dealing with those situations. using this technology?
Yeah. Like I said, within our software ecosystem, we have a workflow in place that we import the model and also the point cloud, and then we start, and then we run our algorithm, which is based on machine learning algorithm, and then it starts identifying the differences or the deviation of the point cloud against the model, and then it highlights those deviations. Then our team goes and see, okay, instead of finding those issues, they put their time to solving those issues. That's how we create value.
I have a question. So at the beginning of your slide, you showed a handheld device, doing the scans. So what's the advantage of using Spot other than autonomy and going into confined space? Is there no value to using Spot against a handheld device and worker walking around the site?
Yeah, I mean, as Sina mentioned, you are freeing up someone to perform more value, higher value tasks, right? As well, there is a price difference,
Yeah.
right? So that's exactly right. That's always going to be considered in terms of why you're employing a certain tool and what it's being used for, right?
Great.
Yeah.
Thank you.
Thank you, everyone.